पथमा दिखला दो, भला बुरा हम समझ सके बस ऐसा विवेक जगा दो, जिस पर चल कर लक्ष्य मिले वो, जिस पर चल कर लक्ष्य मिले वो, राह दिखा दो माता। मात सरस्वती वीणा वादिनी ज्ञान जगा दो माता। मात सरस्वती।
And welcome back to this U.S. Open office plan.
Miller just lobbed a message way over Jones's.
हंसवाहिनी पुस्तक धारिणी श्वेत कमल पर साजे, निर्मल धवल स्फटिक की माला सदा हाथ में राजे। हम भक्तों के शीश पे भी अब, हम भक्तों के शीश पे भी अब हाथ फिरा दो माता। मात सरस्वती वीणा वादिनी ज्ञान जगा दो माता। मात सरस्वती। ना भटके हम अंधियारों में, प्रज्ञा जागृत कर दो, करके दया कृपा जगदम्बे तम हर लो शुभ वर दो। अपनी सेवा देकर जीवन, अपनी सेवा देकर जीवन धन्य बना दो माता। मात सरस्वती वीणा वादिनी ज्ञान जगा दो माता। मात सरस्वती वीणा वादिनी ज्ञान जगा दो माता। ज्ञान जगा कर शरण लगा कर, ज्ञान जगा कर शरण लगा कर मोह मिटा दो माता। मात सरस्वती वीणा वादिनी ज्ञान जगा दो माता। मात सरस्वती।
ॐ मा सरस्वत्यै नमो मेरा कोटि प्रणाम।
गुणों की देवी शारदे माँ, तुमको मेरा कोटि प्रणाम।
माँ सुर और ज्ञान का दो वरदान, तुमको मेरा कोटि प्रणाम।
गुणों की देवी शारदे माँ, तुमको मेरा कोटि प्रणाम।
हे गुणों की देवी शारदे माँ, तुमको मेरा कोटि प्रणाम।
तुझे प्रणाम, ओ माँ तुझे प्रणाम।
माँ अंधकार तुम हरती हो, जीवन को ज्ञान में करती हो। माँ अंधकार तुम हरती हो, जीवन को ज्ञान में करती हो। कर दो कुमति से मात निदान, तुमको मेरा कोटि प्रणाम।
गुणों की देवी शारदे माँ, तुमको मेरा कोटि प्रणाम।
माँ सुर और ज्ञान का दो वरदान, तुमको मेरा कोटि प्रणाम।
गुणों की देवी शारदे माँ, तुमको मेरा कोटि प्रणाम। माँ तुझे प्रणाम, ओ माँ तुझे प्रणाम।
हर शब्द गीत है तुम्हारे माँ, सुर और संगीत तुम्हारे माँ। हर शब्द गीत है तुम्हारे माँ, सुर और संगीत तुम्हारे माँ। मिले मुझे कला में माँ सम्मान, तुमको मेरा कोटि प्रणाम।
गुणों की देवी शारदे माँ, तुमको मेरा कोटि प्रणाम।
माँ सुर और ज्ञान का दो वरदान, तुमको मेरा कोटि प्रणाम।
गुणों की देवी शारदे माँ, तुमको मेरा कोटि प्रणाम। ओ माँ तुझे प्रणाम, ओ माँ तुझे प्रणाम।
माँ तुम वेदों की भाषा हो, गुणी जनों की तुम ही आशा हो। माँ तुम वेदों की भाषा हो, गुणी जनों की तुम ही आशा हो। है बोध विवेक तेरी पहचान, तुमको मेरा कोटि प्रणाम।
गुणों की देवी शारदे माँ, तुमको मेरा कोटि प्रणाम।
माँ सुर और ज्ञान का दो वरदान, तुमको मेरा कोटि प्रणाम।
हेलो हेलो कॉर्डलेस नहीं नीरज हेलो 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 ଏ- ଏଇଟା ଜଣେ ମାନେ କହିଲେ କିଛି ଜୟ ଜଗନ୍ନାଥ, ଜୟ ମା ସମଲେଇ। ପ୍ରତ୍ୟେକ ଦିନ ଖୁବ୍ ପାହାନ୍ତରେ ସୂର୍ଯ୍ୟ ଉଇଁଲେ ଏକ ସୁନ୍ଦର ସକାଳ ଆମକୁ ଉପହାର ଦେଇଥାଏ। ସେହି ସକାଳ ଆମକୁ ଏକ ସୁନ୍ଦର ଦିନର ଉପହାର ଦେଇଥାଏ। ଦିନଟି ସମୟ ସହିତ ଆଗକୁ ଯାଇ ଯାଇ ଏକ ସୁନ୍ଦର ସନ୍ଧ୍ୟାକୁ ଉପହାର ଦିଏ। ବିତିଥିବା ଦିନ ମଣିଷ ମନରେ କିଛି ଅନୁଭବ ଓ କିଛି ସ୍ୱପ୍ନ ବୁଣେ। ସେହି ଅନୁଭବ ଓ ସ୍ୱପ୍ନକୁ ନେଇ ମଣିଷ ବଞ୍ଚିବା ପାଇଁ ଜୀବନର ମାର୍ଗ ଖୋଜେ ଓ ବାଟ ଚାଲେ। ଆସନ୍ତୁ ଆଜି ଏହି ସୁନ୍ଦର ମୂଲ୍ୟବାନ ମୁହୂର୍ତ୍ତକୁ ଆମ ଜୀବନ ପାଇଁ ଶିକ୍ଷା ଜ୍ଞାନ ସାଉଁଟି ଅନୁଭବ କରି ଜୀବନକୁ ଶିକ୍ଷାମୟ ଜ୍ଞାନମୟ କରିବା। Respected dignitaries and my dear students and colleagues, I would like to welcome you on the third day of FDP program. Today's session, we have two personality, dynamic personality. First of all, I would like to call Dr. Pradipta Mishra, ex-scientist of ORSSC Bhubaneswar. Sir is very kind-hearted and simple person. As a scientist, he serves for the nation for several ways. So, give a huge round of applause for Dr. Pradipta Mishra. Sir, please come to the dais.
Morning, all scientists already slide 20 to 30 years in chat. Whenever we opportunity to come, people themselves reserve for us. So I just share the experience of you how the remote satellite basically helping us in the field engineering. So some people, whenever about say remote, try to master some it is run now they close physiology people chromatic. What are the frequent mathematics? Port or RSI. We mean mandatory or right maybe no area of field drones some carrier port you UAV mean you are the will come back position it is that has been decided that each headquarters in the block of its own will be it through the ground will at place the survey it will get to the zone idea of the port HRS frequent for engineering do not very coarse satellite is always require one or a high range satellite very high satellites of say centimeters spectrum that require meter spectrum image. Them digital model GPS navigation GPS allow in your own GPS, but we know that always rent last 10 hour differential listening or the or no so we have that I said in that we limit when you so I get the from the fashion satellite today's stock is image so but with that we improve and for the doesn't the basic in GPS and that GPS plus or meter digit millimeter so and different so you ask me say your smartphone GPS there on your photograph say village of area that is happening the longitude there is a difference the battery clock is our mobile or the smart and say the heated in sea region very information the GPS mostly able like two company in model of India that like right now Chinese company for selling the authorized similar so in KV where you so 5 PLB get DJ one company DJ Oxford like say the 5 lakhs so there people out survey banned now they are the bone in the stomach the say right now thing near 12 lakhs in that we don't where we carry then much more safe meter, 1 meter, so we can with that drone. GIS, though I using the software in GIS or quantum GIS using generating data value is not set to the not set to source platform on web GIS. I will total human types of app has right now. Then there artificial machine last month. This is sent which connect satellite to new that satellites can new civil for billing in satellite window it is high result like cannot give that performance for that ground require and distribute like drone like I type of artificial intelligence machine and along also so the step should require the types of drones this is a fitted like also be a drone and you can own it is right. Suppose I formally I will have a different if I a multi image I will different idea that is the other the type snow type can to micro small medium and note that you see student is that drone whose the must be hired by the if the type certified GC that is nothing. Repeat the company where if you go the drone DJI dynamic but not this directly to the image resolution image. So we tell you it has component 4 characters virtual and real third metric 4 temporal spectral if divide electromagnetic term in filter so then particular color can length of the shutter interact with the can be captured. So if four filter system, four different system, the satellite move Solpur Kerala right, I will get different images. Since they one another infrared and Malin. So I will get four satellite of area seen the blue color that is there whatever So sun is it conduct infrared labeling are there. What has a tendency to what blue towards that if I keep a filter over the stump and only the will be captured, I want the cementous problem. So we take two filter camera and whenever it or the move, we get a blue reflecting from the reservoir and we capture. So clear water is remote pixel by if it is my it will be 250 right that man with the elements see plan the plan any type station click and increase pixel by 45 50. If I take that set I calculate if I out in deep water I can with your water which areas I execute. Okay, suppose that same station chloro they high in region. I have a system red filter red feet per vegetable they are reflect will be kept in a very manner. Wherever vegetation are red band it will with a blue of high vegetation not the pixel very less and carry out now difference sun index. So if I blue band, green band, and red normal so set there they have a high satellite come up till they not have sensor sensors but that in but in we have combat oh in this application we are sensor in the craft in this so that keep it channel 100 people so in area will get satellites so the so called model for seeing get different types of images where can analyze band you can take bands that in your so the basic of the where is imagine here you can create your false color or composite take band time rest of the image and of that NVN analyze it like it that is the where for image station analysis other you cannot with the math right now into is this the again a few regular pros suggest a few said that browse the Goa pros suggest so what the high satellite memory for our world full develop database star world thing is someone why will if I for irregular satellite from the foreign disk or plan current. Odisha wide 7 square we have to pay to total cost is nil crore. The of cost 2 lakh. Why I take the image? Why should I take the error not from be UPS limiter per symbol per but there is created a Odisha area then Sia and then the entire inherent error should be arranged. The value is number one, what to not stop with that very old months back. So we is to suppose to see Budla or big city satellite image, current image Google is the what you tell me individually for we should you browse the day. Say you are full, people in your teaching and only you will at people they that son of is how so okay one will find our area right in very up. So that is so I am carrying project VSSUT area or command the satellite. I cannot put satellite image. So sometimes we don't face difficulties with our project get 10 lakh the stages. Massively student can please close that every that automatic will be updated. You have to reference that the help say you satellite or take a observer along with that satellite and how it will use can save this very request come at stream for it correct Malati having that box to see the satellite high range satellite 30 that will inject a meter in centimeter the ground through the of the 30 meter in centimeter. Just imagine this centimeter. So that can happy cyclone has happened and basically this is to damage of the department in government of DC is and the the damage to that such had data and if that are there you can download that. You see station you see damage to the railway. This is why the satellite. So I was totally forgot to one speculation that divide with image station into bands different color. Another is Partial means to aid. So small that can be captured satellite sensor is your say clear it to 20 100 20, then to 35 meter. Of India has 2.5 meter and 1 meter. Sat we are but get for civilian they are not to use that 2 3 that getting for very area there to bring the say give it to another day. Once you get like that region will are charging the but when set there satellite provide the Houston storage the name is 3 giving that in one point 30 into 30 centimeters. This is image of say that grid is there. Grid is this is in the main पूरी बॉडी every in the plot one identity you see over it there. No, I am showing is a variation dimension you can up the tank light image. I get of that tank get directly height of the from this search possible say it is possible it is possible so you here if you there is between tabs you are below the scope with 3 view measure same adapted satellite over here to it is other side one thing has here to get video in this area that can be and it picture same area there is one over light image particular you read the dimension picture area get a 3-dimensional chart also the digitization model soil or digital terrain model that generate the and also not of it that is much but object that is the photogrammet have a please now only the photogrammet I am using photo I am satellite measuring from that I digital and of that digital photogrammet will find 99 people in that are civil background are from engineering back medical no nothing engineering now stand can say here this is the pad and there one type person you this is information height also get overlap. Another there resolution is partial radio resolution. What radio measurement is on? How to measure radiation? Asking beyond the topic, asking you, okay, to students the for purchasing their purchase on bit resolution camera. That purchase they bits different 6-bit resolution camera and 8 camera. Can anybody 6-bit resolution is 8-bit is the same ever can use this one. The American place satellite called it fitted smart cameras, smart cell. Satellite captured the of the earth. So tell me, bit. What do you mean by the color? To it. My minimum zero value is 5 bit to the power 64. Minimum will maximum 3 because range from 0. 8 camera they take through with camera with camera the camera with single device the possibility in the best way 6 class sum of camera. If I am using with the end the same thing divide that 250 classes. If I am of 8 the satellite that divide into 2 chances and divide into 6. That is another I am asking you related image to smartphone to camera that we are going using. He told that I have the 8 cell camera second. What do you megapixel? These are satellite thing. The answer is whatever camera down. And what do you mean 8 mega? My mobile 8 mega. My IP is mega. What does it mean? Picture, okay, PL picture. Scene when it is move or capture of smartphone is called scene. Million. Okay. If but my smartphone is 8 megapixel camera, professor has a 10 mega camera, so we are the same. Okay, camera entire speed to take 1 pixel square. Pixel will have a radio resolution. Okay, spectral spatial term temporal position across city on 42,004 are at say 9 kilometer revisit Urla meter 8. That is the okay slow. In your survey, it's like of civilian civil purpose square 30 centimeter mine set launched by row or very near the earth. Once it near the surface, they item 100 kilo general slide remote slide at 900 kilometer 9 kilometer it will for area it be 18 but satellite height of kilometer or it will reach same area days. If I sat or you 3 it will reach area after so again facility suppose car related culture to stop sequence 3 days. Day it is passing then from middle spark tilted spark here equation national emergency. Think any light image for an Indian report to national remote or not directly from satellite. So you have, if we height of kilometer, it will be very resolution. Resolution 30 centimeter can light image of a pixel 30 to 30 means 900 meter be help possibly or centimeter to 30 resolution full for an year. Meter that is high light. Please remember for sharing for high degree high and satellite image. Now we are working with that you are that very and I contour 5 meter 0.1 generate technically through the image or for the satellite for Veda you see binary from the image is related. Type of image you think can generate either stereo photography stereo or I have this okay. So it is I have the image is 2D picture okay. Later I can but I get the height I have PS 1 side DGP particular it give the longitude altitude if I roving inside parts of the area so get to longitude altitude to or value I get it real picture like up in this is due to image black and white say 50 cents per channel from you can the height bar and can any what is the what is this why you 2000 image view centimeter 3 month Jagannath. One said, this is the end. My side from 2000 image that I am giving any severe here. This is meant pass Mary. You kindly use download the image temple mark after what are this is all these then calculate already told you sparse means area can you can get what difference before 2002 or the parikrama started before that the view item can come. I am coming that topic time gets you. Sorry, take slide. Sorry, okay. Oh, and to here the control projects. I have so written changes. A few last year have got CB area. One changes marked there. Yes, the image that in all quite old and student out that character do or think see the message then image eroded this we carry cross and the as sign that is known as very right high it acquired by SCL college of construct come up. Another I am giving you to say slightly 1000 of Asia another yatra and slightly of 720 Mari Google kindly engineer kindly says the in that and what change. Can you draw section long process from that? This is the age of remote satellite remote sensing not rest. The people are these remote sensors. This is the job satellite image. I was telling you हम नो digital model national data available of course available you go to them just browse search them write down find the also any about one is one please note during take HD one you will NRSC it is in that giving any of height satellite point and of India meter cost. Of cost. He said like 5 point big high 4 meter meter that is high. The light image get you can do 5 point is also full for linear. So that if I was that can you draw diction alert that all possible one is there. Just to spend time with you have this section carry out null section type of cross section carry out from a book of cost. It is your that means first point of view cannot calculate. And I am so why is not the engine present the policy for Rogers and team the GL to 50. These are partial ODCL that 2000. Permission it's a is based drone images that are developed somebody be other people. So they can present you any of that. You write you access space application that type of information where and we provide us on the OS and research for policy 50. And is once payment at project. So I have here you all see two web there most sonographic data center civil engineering two on the other say interest as you can from the inputs say tower telephone or electrical fish wage in but spatial can or marry satellite but two can say the types of says what we directly input from the image but those are reachable second water so redemption groundwater intentional you give you 100 say 9% information water face water I can give 9 accurate in on agriculture in the area on irrigated drought all these where but give 100 information 20% on groundwater but in that true image only for soil and no moist satellite I can soil from what if you are the policy value assume by soil 1 millimeter will give you light but give you soil where type soil boundaries and you see this is the that for able thing is that your canal doctor also heard in for problem. So if uh, turning square 3 day wetness index value of down download go to mostly class that dot it's a support 3 times it gives a soil index wetness in soil index or very soil one very very uh, in a water log it taxon you will go to water sections some of or area very moisture will bring wetness and I out an area here and here getting you the point to and that area is the current wetness actually land and is get through of the sense relation land temperature, surface pressure and current land temperature. LS divided by max LST min get the oil vertex. This is not that high to possible I will 10 lakh unfortunately. I am giving every time students and you give this open data not one source so one item is which dimensional I cannot get percent from image I can carry out of analysis only noise chance that I view from image. Anything see your web put up photo post for 4,000 only you is any putting out whether upland or water or particular your canal whether through or it is through a forest land or it is through a say other or private land. You can know plot in Odisha which bound plot bound. Suppose particular can know on that what is the duty of your plot can know. This scale up having to that during long will discuss this. Then you can mention that we had to get direction from the satellite. If I am giving you high resolution light, you can get 100 factor or centimeter 3 times possibly better than physics. So get better in from the image say preparing an information or a crop related modeling and get it done satellite not give emphasis swing and for two items that you resource up they can get and we because possibilities we require an ground day after 2 years for then an engineer or engineer and access supplementary to find a bull side or well particular so uh, this will help that rating. It's all about information. So the field taking rehire satellite by so in the by have bound the lot bound so root over the satellite will pop match. Lot number owner my रखाई एंड्रॉइड बहुत सारा रखाई थी वो साधारण गवर्नमेंट पब्लिक दिस information get which is the or bill in also to urban I'm one percent of map in Hindi state the SRAM map and having place your parents this map plot in we call it ATAL map. Okay, particular and in use your drive in the your star this because I resolution image I want to the exact the object so in this set that known as this process and knowing else in government revenue department and the other have been yearly sent to six and declared that they are the last 7 they have your correcting cadastral entire road 4 years diploma or you see here this is the area they are the where we can observe one see the observation is the latitude land sun over bridge on a sea cross take the dash value latitude and on that do the activation of image job ground resolution image for that you have do the information where most or that also you draw for this stuff for total map station say road canal this thing this is gift है all in water or map related. With this in the final map. If I am engineer engaged in the urban apartment type of bell or up road के high range में map road then integrated you see this is a number is 0 cadastry match right image. So in ROR is the record of घर प्लॉट नंबर 5 सीडीएस क्लिक कला माने बाहर डाटा बाहर तेसोडा आईसी वी database here say नहीं काडा सुपर impolite but is there can know when it and suitable whether it's suitable can or road do pre Islam to good part color information you go type of only I am butter पूरा स्लाइड पढ़ेले एगुड़ा last time more when moving but nature is showing watershed number, and how many of you involved or have you concept management will ultimate water management is restore, okay, restore conservation education. Education is the goal of seniors. What is your say inside this presentation? I will be showing you how groundwater can be ascertained from remote sensing data. So, watershed is a geohydrological unit which is drained by a system of streams passing through a common point. That means the entire drain, whenever rainfall is there, if the entire water at the time of rainfall is passing through a common point, then the catchment area smaller in smaller sense is called a watershed, and it has classification system you see here. So, that is the common discharge point in the north line, and you take the ridge line of the hills, that becomes the boundary of the micro watershed. India has, and the classification system is region, basin, catchment, subcatchment, watershed, subwatershed, mini watershed and micro watershed. Okay. So, India has 6 and it is all in the database is in digital. So, any place say VSSUT area, you click on the data set, you can know what is the micro watershed of that particular area beginning from region. India is divided into 6 water resource region, and our Odisha is coming under region number 4, all drainage flowing into Bay of Bengal except 2 and 3, except Ganges and Brahmaputra. Any river flowing into Bay of Bengal, the catchment in broader sense we can say it region. Okay. So, the region is 4. That means any micro watershed I am working in Odisha, the digit or the digital coding will start with 04. Okay. Then after region is basin. Region, basin, catchment, subcatchment, watershed, subwatershed, mini watershed, micro watershed. So 8 classes are there. If I give 2 digits to each class, then for 8 classes it will be 16 digits. So, for the entire Odisha, even right now after Odisha also entire India, they have completed digital classification of micro watershed. If you have the watershed database, you click on a particular area, latitude, longitude will come up, the digital code will come up, the administrative boundary, everything will come up. How many of you have seen this type of place? Who has seen watershed program plex? Many of you might have seen, but I have ignored to watch this. This is the 90% or say not 90%, 70% of each micro watershed activity is carried out by civil engineers. 70%, 30 for say 1 kilo for 30 lakhs comes for 5 square kilometer micro watershed area. Out of that 30 lakh, I think nearly 21 or 22 lakhs is being spent by one civil engineer. So, I told you it has 8 classes: region, basin, catchment, subcatchment, watershed, mini watershed, subwatershed, mini and micro. So, watershed part of region, my water region starts with 04. Then basin, Odisha has 4 basins. So, this is 04, 07. In which basin we are right now? Mahanadi basin, isn't it? My VSSUT area is inside Mahanadi basin. So, my region is 04, my basin is 07. So in the computer, in the GIS, I will code it 0407. Then you see number of catchment is 9. 9 catchments water again. So again I am here, my catchment is 040701. Odisha is divided into 37 sub-catchments. You see the sub-catchment number, classification also. Can anybody tell me where are we now? I think we are here 04, 07, 01, 02. That is sub-catchment. Then Odisha is divided into 205 numbers of watershed and 20,259 micro watershed. 20,259 micro watershed. Odisha is divided. Then I am coming to a particular micro watershed. How priority is being carried out. If this priority, suppose percentage of wasteland, if micro watershed has more than 40% wastelands and slope is more than 10% and SC/ST population, this is the criteria adopted by government. They say that SC/ST population is more than 50%, then that should be treated fast by the soil conservation department, by the civil engineers engaged at soil conservation department. Okay, so for all civil engineers, you must have the concept of watershed classification and all these things. So in GIS, you go for GIS based analysis. You see, this is 4 micro watersheds, 5 micro watersheds I have taken. This is the drainage. This is the percentage of SC and ST population, and as for that, priority watershed slope percentage, and out of the GIS analysis, this particular micro watershed has all the 3 criteria. 40% wetland is there, more than 40%, more than 50% SC/ST people is there, slope is more than 10%. That means the watershed concept says that the hilly or the sloping areas must be treated first to arrest soil erosion. Okay, this is the main concept. So if it is a 10% or more than that slope, then it should be treated first. So we selected this area. Then I am coming to a particular micro watershed where we will discuss about the groundwater. This is the particular in Devgaon block of Balangir district, one particular this is one particular panchayat is there, Kundeimar. You see, this is the, you see the entire water of this micro watershed is drained at this particular point. For that reason, it is a micro watershed. This is the cadastral map, geo-referenced, put over the satellite image. This is the satellite image. Can you see, we have, I have shown you nearly 30 or 40 satellite image. Right now it is my time, I will ask you a question. This is a satellite image. I am telling you, can anybody tell me what are these red color features? It's a false color. Deliberately, whenever you go to a particular field condition, which feature attract you more? Which feature on the earth surface? The greenery. So the greenery or the areas where chlorophyll is more, that area has been captured through infrared and red color is assigned. Not that it is bound to give red color in a false color composite, but mostly you will find whenever you go through the textbooks or say through internet you browse, you will find satellite images, the vegetation area is in red color. So this is the sloping area of this area. And what are the blue color? That is water body we have given. In the computer you can give any color. You take 3 bands, you can give any color. But the standard says throughout the world everybody gives chlorophyll red color, because red color is more attractable. Then blue for the water body. You see, I have prepared the land use of that area. Leave the land use. That is not the job of the civil engineer. This is high, say, I have zoomed it. Wherever greenery is there, water body or say crop, aquatic vegetation, anything you can interpret from the satellite image. It is very easy. You see here, this is the main, say, focus of our topic. You see here, I have prepared a hydrogeomorphological map. Geomorphology, you know, hill, pediment, valley, plain like that. Then hydro, from where I can get the hydrological information. Basically, this type of, here I have written one word, lineament. You see, what is lineament? Can anybody tell me? From dictionary I am asking you, not as a remote sensing scientist. Lineament. Once somebody told you lineament, what does it mean? Linear feature, isn't it? A road is a linear feature, a railway line is a linear feature. In the field condition, canal somewhere it is curvilinear or linear. Similarly, but in geological term, in hydrogeological terms, any fracture on the earth's surface, and though it is not traceable through the naked eyes, it can be traced through the satellite images. Okay, the concept is the small fractures on this earth surface, say 5 kilometer, 1 kilometer, 2 kilometer length, and say 5 meter, 10 meter width, which cannot be identified through naked eye on, but can be identified through the satellite image. Those small fractures. Once there is a fracture on the earth's surface, all the movement of moisture, all the movement of surface water goes through that. And what is the concept? Whether there will be more traffic, just common sense I am asking you. Please be attentive. Suppose there are 2 roads, one road is there, another road is there, and another road is crossing here. Whether there will be more traffic at the cross section or along the single roads? At the traffic, similarly, at the traffic means at the cross section. Similarly, I told you lineaments I have drawn from the satellite images, the linear fractures on the earth surface. Whenever the linear fractures intersect each other at that particular point, that is the highest suitable site for borewell tubewell. That is the concept adopted by the hydrogeologists and remote sensing scientists throughout the world to find out the location of deep borewell or tubewell. Okay, only thing is that you must be one expert in geology, because you have to know the lithology types of rocks. You side by side you can interpret the lineaments. Side by side you should have the knowledge of the satellite image. So once you draw all these things, then slope you can directly map from the satellite image. Soil, you have to draw the boundary, then field work you have to do. This is land action plan. You see here. See, I have drawn buffer of 10 meter along all the lineaments. Then this is the cross section of 3 or 4 lineaments. Then as a common man, as a civil engineer, as a common man, what I will say? That there is a chance of getting good groundwater at that particular point. So, suitable areas for deep borewell, all red color at this particular. Suitable areas for shallow dog wells, the valleys, the low-lying areas, blue color as well. Settlement, renovation of existing water bodies and proposed site for check dam. If you know the logic of check dam construction, then I can give you the slope, I can give you the drainage map. You just put and with the GPS or the GPS, you go to the field and pinpoint that particular area for check dam. What is the logic for check dam construction? Can anybody tell me? What is the best suitable site for check dam construction? You see, once I zoom, this particular plot is highly suitable for deep. I have already digitized the cadastral. I know the plot number, I know the village. From the NIC ROR data sheet, I can know that this we found the beneficiary name. Then we called that person, the present chief secretary was the director, watershed mission was that time, he is basically a geologist. So that was an experiment and it was a great success. One Subada Pradhan person, it was his land, so we got the 100% success in that area. So this is the two aspects. One is your groundwater, another is soil. Other things, forest, say surface water, all the type of infrastructure, buildings, everything as a civil engineer, you want to know the concrete buildings. As a civil engineer, we carried out a project called slanted roofs of entire Odisha. We have the high resolution for solar projects, solar top for this. Today, I think Government of India launched it. If it is slanted or plain roof, okay, concrete roof. So we carried out the analysis. It was a huge job. So all the slanted buildings, we carried out concrete buildings and gave it. Those work can be done. The only challenge is that how to find out the groundwater site, best site, and how to know the soil. And lot of open source information portals are there. Please note it down. Bhuvan, BHUVAN, and ISRO Bhuvan. If you just browse it, you will get all the information due to from the satellite image based information related to groundwater you can get, or any type of information. So any question, please? And lot of slides are also there, other slides are there. So students, Professor Sir is there, you can take my number anytime, anything related to remote sensing, you can ask me. I am presently retired, though I am working in different areas, I can answer all your questions. Thank you.
Sir, our association just started and it will continue. Even if you retire or not retired, you are still in job with us and we shall be continuing. And perhaps our students have realized what is the importance of remote sensing and the job has just started. For me, I have like just the groundwater part. It's very much of India and simply how the how utilize value in detector source. So that it was a composition and students those who are working or even not working, simple how Google Earth is beautiful, how Google Earth is beautiful, and how you can utilize Google Earth also. So that is the main theme of sir's lecture, and perhaps you have realized everything. Thank you, sir.
Thank you, sir. Thank you for your valuable words. Now, I'd like to request our second session, our chief guest, Dr. Asutosh Das. Dr. Asutosh Ratha, Professor of Civil Engineering Department from Silicon Institute of Technology, Sambalpur. He is working as an Assistant Professor of Civil Engineering in Silicon Institute of Technology, Sambalpur since 2013. His expertise on irrigation, water management, flow management using ADV flow, tracking application of crop water, modeling of groundwater, and artificial intelligence. So within 2 minutes, we will start our second session. Thank you.
Earlier, we have seen most of the things as smartphone, smart apps are there. So many smart things are there. But now we shall hear how the irrigation can be possibly be smart. So for that reason, also we have invited one student from Indian Public School of this Sambalpur, that he will also practically show how the irrigation system can be smart. So please give a big clap for one student. His name is Siddharth Jain. He has arrived with his teacher. So let us see how he has made the, because I have gone to their school for inaugurating one science exhibition, and out of many projects I have found that this is a very beautiful project, and that is a very household project, and he has resolved that, and how to resolve these irrigation problems, and perhaps he has done all this in a flower pot. For the flower pot, he has resolved the problem, and we are thinking bigger on that, because we are when coming to the field irrigation system, canal system, dam, reservoir, if that thing will be applied. Now we shall be watching our he is our student. First of all he is a student of VSSUT. So now he is in a different platform. So we shall be hearing from how the irrigation will be smart, and later on we will be watching how the irrigation has become smart. Thank you. Ashu.
Thank you, sir. Okay. Thank you, sir, for nice introduction. Today, I am going to present very interesting topic, that how artificial intelligence is useful for water resource and what is smart irrigations. So, this is the sequence of my today's presentation. What is benchmarking, what is resource management, and what is artificial intelligence I will tell. Then I will tell how artificial intelligence is applicable to water resource. Then I will tell something about the smart irrigations. Then I will show a case study how we have applied the artificial intelligence for development of irrigation sector in this particular area also. Then ultimately conclusions. So we'll start with a very useful term, benchmarking. So what is a benchmarking? It is a management term. So basically, suppose I'm here, I want to improve somewhere else. Moving from a given situation to a higher position, that term is called, that process is defined by the term benchmarking. Now, how can I move from one place to other place? And what is the significance of the term benchmarking in this particular lecture? Today we are talking about the application of artificial intelligence. We are talking about the smart irrigation. Why? What is the purpose behind it? Because at present we want to improve whatever situation is at present we are existing. We want to improve the present scenario to a higher level. For that reason, we are applying the artificial intelligence and smart irrigation. These terms are coming into use. So basically, whenever you want to move ahead, three terms are highly essential. First, analysis. What is the defects or what are the scopes of improvement in a particular system? That part you have to find out. Second, comparisons. And third one is proper strategies development is also required. So you can tell me, you can ask me why benchmarking is essential for the present scenario, in how we can apply that technique for water resource management. In that case, you have to find out the efficiency of the existing system. If we go for construction of a new irrigation project, as sir told, it requires a lot of approval, financial implications, environmental clearance, so many things are required. So instead of opting for a new project, we can go for this. Can we remodeling or modernization of the project can fulfill our aim? That part you have to find out. Then cost another factor, and third one is your how efficiently you can use our existing infrastructure. These are the points which are required to study benchmarking technique. Now, water is a resource. Why? It is a very gift of God, and why it is called a very important resource. Although in the world scenario, 79% covered with water and 21% is covered with your land. That is, you have already read in your class 7, class 8 classes. But out of that, only 97%, if I take this 79% as a 100% scale, out of that 97% available in the oceans, means not in usable conditions, and only 3% is available as the fresh water. And out of that, 70% are in ice form, only 29% in ground level, and only 1% available for all to meet various demands. And as a civil engineer, you are aware with the fact that out of 1%, about 80% of water is meant for 70 to 80% you are applying for irrigation system. So what are the challenges? How can we manage so many things? Your municipal supply, your industrial demand, your irrigation sector demand in the 1%. It's a big challenge for us. So what are the challenges ahead of us? Let us see. Basically, in the water sector, the major challenges are the quality aspects and the quantity. So both quality and quantity are the major challenge as of. So what is the quality issues? Population is increasing day by day, so definitely water use will increase. Sanitation issues also coming into use. Gradually depletion of the groundwater as are told. Then intensity of irrigation also increasing day by day. Again, the price of water can contribute to the water existence. Means suppose we want to convert this saline water into fresh water. So many proposals are available, but for that you require a lot of investment. So money is a constraint. So these are certain points I have cited for the quantity issue. Same time, if you go for the quality issue, you will find the use of fertilizers, pesticides, then the industrial waste. These are the few things that's creating day by day challenges for us. Now, apart from this main quality and quantity issue, some of the challenges are interrelated. They are secondary but very highly effective one, just like your economical value. Economic point of view means whenever you go for any type of new constructions, any new projects, you have to go for a lot of investment. Second one is ecological issues, the how to stop the degradation of the ecology, how to get clearance from the environmental EPI, then social issues, and third one is technology issues. A lot of technologies are changing day by day, but people are not aware with the facts. So how to make them aware with all those things? This is the major challenges ahead of us. So once we know the challenges, so what are the major objectives as of? How to deal with those challenges? It is the major objectives. So out of that, first one is our ecosystem. second one is health, and third one is water cycle. These are three are the major issues, major points we need to take care. So when we are talking about the ecosystem, the climate change is a big threat to us. How to deal with those issues for our agriculture productions? It is highly affecting our productions. So we have to take care of those things. And many times you are facing the extreme events like flood, drought. We have to take care of those issues also. You have to find our application and solution for those things. Similarly, it is our duty and responsibility to provide a good quality of water and good quantity of water to each and every human being. Then the closing of cycles, water cycle means, this means water cycle is the basic fundamental thing of our water resource engineering, water budget equation. I think everybody have covered that one. So in the closing of cycles means there should not be any loss of water during the entire process. So in that point, what are the things we need to find out? We have to find out, analyze the water footprint, means in each activity, how much volume of water you are using. How can you make the water use in a judicious manner? That is also a very important part of us. Second part is your aquifer recharge and soil aquifer treatment. Artificial by infiltration method or by deep injection method, so many methods are available for this aquifer recharge and soil aquifer treatment. So these are the things we have to take care for this to meet the challenges. Now, the integrated water resource management. The overall development of the water resource system can be possible if we go through the integrated water resource management. So what is the integrated water resource management? The water resource system consists of many disciplines, many subdivisions. If you starting from the groundwater, irrigation, and your river management, so many power generation, so many things are river management, so many subdivisions will find in the branch of water resource. So how to make them improvement in each sector so that entire system will move ahead? That is the major challenge ahead of us. So that is coming under the term integrated water resource management. Now coming to our main topic, application of artificial intelligence in the water resource. So artificial intelligence is no more a new topic for any civil engineers. Still, before going for the application of artificial intelligence to our water resource projects, I will just some slides, something about the what is artificial intelligence is and what are the very fundamental things of artificial intelligence. Artificial intelligence consists of two terms. One is artificial and second is intelligence. What is artificial? Which is not natural, is artificial, which is not man-made. And what is intelligence? When we are talking about intelligence, boy, what is intelligence? Capacity to learn and capacity to solve the problem. If very quickly he can learn, if very quickly we are getting the solution from that particular students, then we are considering that boy as a intelligent boy. Like that, here we are developing a computer system which can work like a human being. That means instead of the taxes are tedious for a human being, which can be easily covered up or which can be easily performed by a machine, we want to develop such a machine, and that machine is termed as artificial intelligence. So basically what we are expecting from that machines, it can act and behave like a human being. Secondly, it act rationally, means logically it will work as well as it will work like a human brain. So this topic is very not new one. Since 1950, people are working on artificial intelligence. It is not a new one. So this particular gentleman, Alan Turing, he had developed an experiment to say which computer can be considered as a artificial intelligence and fit for artificial intelligence. For that purpose, what he did, he took two human and one computer. One is played the role of an integrator, and two are the player A and player B. The person in the cabin C is not aware where the computer is sitting and where the human being is sitting. And ultimately, the integrator C send some questions. That questions through the keyboard and screen. No communication, verbal communication. So ultimately, the C received answer from both A and B. Now, if at all this C unable to know which one is in which room computer A is sitting and in which room the human is sitting, then in that case it is pass. That means in that case the machine is fit for can be defined as artificial intelligence. That means that machine is thinking like a human being. So this is the very fundamental test from 1950 that people were talking about the artificial intelligence. But we are finding a lot of applications in the case of civil engineering, in all field. You go for transportation, you go for soil mechanics, you go for anywhere, we'll find a lot of application of AI. Basically, the reason is, I think so, at that time, initially we were talking about the offline data collections. Then you go for the real time data collections. Now you are how the future will be. We need predictions. So in that case, the use of AI has gone up. And second part is very important one is the use of application has gone up. But previously, the computers were not so much processing power or memory power, but nowadays, as I told, a lot of data can be available in online mode. Cloud computing situations are going on, so it is available to us. Yeah. Okay. So what we need? What is artificial intelligence? Thinking and acting. Two different operations to be conducted. First is you can think like a human being. Next, you can act like a human being. That is the two thing. Logically think like a human being, and you can act logically, and you can act more efficiently as compared to human being. Then it is called artificial intelligence system. So what is the goal? As I have told, the goal is to more useful, letting them to dangerous, tedious tasks of human being, time consuming tasks, more prediction work, lot of data handling. These are the very dangerous for a human being that can be done by the AI. Then they can understand the human intelligence system. They will act like a human. And these are the goals of the AI. And some of the foundation of AI means there are some basic things of AI. First one is complexity theory, degree of belief, probability theory, and utility theory. So what is complexity theory? The complexity theory basically means to solve any complex problem. Complex means any type of analysis which require lot of data handling, lot of accurate predictions. So the complexity theory, that means we can divide the entire task between human and machines. So what is the role of human? The human people, the man will write the algorithm and the computer will try to process them. So very combinationally they can solve the complex theory. So basing on the type of complexity theory, it can be of various stages, just like you can declarative one, then I can go for procedural one, then you go for neural process. So many processes are available through which we can deal with the complex theory. Now degree of belief. What is degree of belief? That is based on the probability theory. 0, 1. It may be, it may not be, or any value in between. I can take a very simple example. Suppose you are going to market and you wish to buy a mobile phone, and the man will show you, the shopkeeper will show you two phones, one local brand, another from the good brand. So definitely your belief will be more on the new brand, better brand. It may be Samsung or Apple, anything. So that is degree of belief. So whatever assumptions, whatever data you are going to use in the AI should be an authentic one and should be accurate one. Second is decision theory. When we take any type of decisions, it's combination of probability and utility. So I can take an example to explain this theory. the probability and utility theory. Suppose I want to catch a flight from Jharsuguda, which is normally I will take 1/2 hour from Bulla to Jharsuguda. So it is ideal time. Suppose anticipating some type of traffic jam or something like that, if I instead of going exactly 1.5 hours, I leave Bulla from 2 hours, before 2 hours. Then it is one type. Another, a person will say, no, there is possibility of any traffic, anything in industrial area, there may be possibility of accidents. Then he will leave for Jharsuguda 5 hours before the scheduled time. So what will happen? Any person leaving for Jharsuguda 5 hours before the scheduled time definitely will reach the airport in time. Whatever may be the situations, he is not going to miss the flight. But reaching much before the departure of flight at airport is not a utility theory. It cannot do this misutilization of time. But so we have to take decision in such a way that the probability should be +1. At the same time, whatever decision we are taking, it should be utility 1. We can get maximum benefit from that particular decision. So it is combinedly called bias theory. So designing any type of machines is not sufficient. In that particular machine, you have to go for the psychology of human being should be there. Now, and application of computer science. These are the two fundamental points for any type of AI machines. That means when we are talking about the human being, he has to take the certain, with just like a human properties, some because he should act like a human being. You should take responsibilities. Then without harm to any people. Then your data should be conserved properly, should not be leaked out. So many things that psychology of human being and some ideas of human being that machine has to take. Similarly, the computer system should be an efficient one. For that reasons, definite large computation power should be there. They can able to perform the critical tasks as easy as possible. And these are some core principles of the AI machines. Your learning, knowledge, planning, learning and communication and perceptions. So we'll discuss this, what is reasoning, knowledge, planning and learning in the next slides. But perception is very important. First, I will start with perceptions. Perceptions mean a human can visualize his environment in which I am here. I am in a class, so many students are here. This, how can I able to know? From my sense organ. Similarly, I can hear the sounds through ear. So these are the sense organ that will help me to recognize my environments. Now the question is, how computer can sense? How can computer can perceive? The processor of computer is in the form of input data. If we provide input data, which can be easily utilized by the understandable, the computer can able to understand those data in an easy form, in the format of computer, and that is called perceptions. Okay. Now, the few points on which the entire AI system is depends: search, representation of knowledge, planning, learning, natural language processing, expert system, and interaction with the environment. What is a search? Suppose my target is moving from here to there. So many ways are available. I can go from this, and this like that. So there are two types of search is available. One is blind search and second is informed search. Search means moving from my starting point to my end point. Starting point to my goal point. That reaching from starting point to goal point can be achieved in two different ways. First is blind. Blind means that is my goal, this is my starting point. So if whatever ways available with me, I am not aware with the roads. If I go move, whether I should go for this road or this road, but this is my goal. That one is my goal. So what I will do? I will go there. I will take some time. Then I will take decisions whether I should go this way or this way. Then I will take a decision. Then I will move next step. Again I will examine. Then I will take decisions. So that is called blind search. In this type of blind search, no guidance is given. to that particular instruments or machines. But in case of inform, suppose by moving this road is 300 meter, by this is 400 meter. If I go by this, some obstruction will come, traffic problem is there. So I am already informed about the problem I am going to face. So accordingly, I will take decisions. So that is called informed search. So by these two methods, I can reach my goal. When the data is full of uncertain, when the task is very tedious, so it may possible that we may not get required informations. In those cases, you have to go for the blind search. The second is knowledge. How we will get knowledge? Very simple. To take the case of a human being. Sir is expert today. Why? Because of two things. He has learned many things and out of his experience. Learning and experience, two combinations are required for knowledge. This is in case of human being. Why I am talking? Because in artificial intelligence, we are comparing a machine with a human being. So what is for a human being? The experience and your learning. But what for a machine? How a machine can be termed as an intelligent, knowledgeous one? The machine will learn many things with the help of data from the surroundings, from the sensors, from the robots, or something your signals. These are helpful to provide knowledge to the particular machine. Now, the machines also, these are also of different types. Then, second point is reasoning. When we're talking about the reasoning term, for our common people, what is the reasoning? The ability to solve a problem. Mathematically, how can I approach a particular issues? That is called reasoning. The capacity of the brain is coming into use. Similarly, for a machines, reasoning means how to handle a critical problem out of available data. So, in the reasoning also, depending on the natures, it may be very deductive type. That means, what is deductive type? Based on theory, I am going for reasoning. For example, suppose Sambalpur to Bulla. I want to go to Sambalpur from Bulla. It is 15 kilometers. I will take hardly 20 minutes to reach Sambalpur. That is called declarative deductive intelligence. Next one is inductive intelligence. That based on the experience as well as knowledge. What is that one? If I go at 10 a.m., the traffic will be there. So instead of 15 minutes, I will take half an hour. So that knowledge is available. I know Sambalpur is 15 kilometers away. It will take 15 minutes, but in case of traffic, it will take 30 minutes. So based on that, if I take a decision, if I going for the reasoning, then it is called inductive reasoning. And common sense reasoning, next another type of reasoning is there. What is common sense reasoning? Suppose if I am aware with the fact that the things for which I am going to Sambalpur is available at Bulla market also. So there is no traffic, I can easily go to Bulla. That is called common sense reasoning. Another type is monotonic reasoning. What is monotonic reasoning? For example, that process is not reversible. Just rising of song is irreversible. Definitely. Then that means the process in which I am moving that cannot be reversed. It is called monotony. Irreversible. Then non-monotony. Non-monotony means what? Suppose I am boiling a water. Once I am boiling water, it will become hot, and once I allow to cool, it will become cool. So that is irreversible process. It can go off, again it can go down. If the direction of the problem can be changed, then it is called your non-monotony problem. So basically, these things are why we are talking about the knowledge representation, reasoning, to describe the world how it is, how to get the right place of knowledge as per our needs, how to generate new piece of knowledge, and how to deal with uncertainty problem. These are the major things for which we are going for the knowledge and reasoning purpose. Second one is planning and learning. What is planning? Whenever, what is our target? We want to devise, we to predict something with available data. So our starting point is known and our end point is known, and number of chains are also known. So how to link one stage with the other stage, that is the called planning. Okay, sequence of actions has to be find out and give a relation between those sequence of equation is called planning. And is learning. How? What is learning? Learning means generation of new facts, getting new concepts, and how to learn different things. So basically, in our computer, you machine learning you go or deep learning. There are three types of learning we are commonly used. One is supervised, unsupervised, and enforced learning. What is supervised learning? Supervised means a supervisor is there. You take the example of a classroom. In classroom, his teacher is present to guide a student. This is the project. This is way you have to solve the problem. So, in the supervised learning, the input and output are known, and we have to feed the data in such a way that the input and desired output data can be available. Though whichever input data will provide suitable result, that is fit. That is the level data. You can take an example. For example, in the election period, we are going for opinion poll. In the opinion poll, what we are doing? In the opinion poll, before counting, then what we are doing? We are asking the different category of people, different type of questions. They are putting their views, and from that we are giving the result exit poll. That this candidate is going to win and this candidate is going to lose. Exit poll is the example of supervised learning. Then in the real counting, if same thing is going on, the same candidate predict by the exit poll is going to win, is winning. That means whatever data we have collected is labeled data. It's a perfect data. That is called supervised learning. Suppose the apple color is red. If you feed the computer red color, thickness this much, diameter is this much, then you take a bunch of fruits, apple, orange, banana, like that, the computer will pick up the right one, the apple one. That is called supervised learning. So whatever many, if it is guided by some things, that is called supervised. A supervisor is there. And what is unsupervised learning? In the unsupervised learning, the input-output concept is not present. For the example, you take a lot of fruits. In that apple, banana, something is like all types of fruits are available. So don't give any type of instruction. The apple is red color, this much height, the orange is orange color, the banana is yellow color. Don't tell like that. And ask the computer to pick up the apple. So definitely, what the computer will do, it will segregate the various red food in one category, yellow food in another category, orange food in another category. That separation is called your unsupervised learning. That is clustering process. And the third one we are talking about, the reinforced learning. In the reinforced learning, what will happen? Suppose the computer, you are asking the computer to pick up an apple, you have not given any type of directions, then ultimately it will pick a mango. You tell, no, this is not the apple, like a cross. Then ultimately what will happen? The next search, that particular computer will not take this orange and it will show you this one is apple. That is called unsupervised learning. That means in the learning process in which one get knowledge out of experience is called supervised learning. Miss, Unelli, sir. Unelli. Now, most important topic, the classification of AI. So artificial intelligence system can be mainly of three types. One is ANI, AGI, and ASI. ANI is the simple one, single input, single output. You cannot execute the complex tasks through the ANI. When you're talking about the AGI, it is, you have seen the supercomputers, ever learned about the supercomputers? That computer that work like a human being, that can able to solve a many problem. That is called AGI. At present, we are dealing with the AGI system. The supercomputers are available almost. This our university also it is available. Now, coming to last one, artificial super intelligence. It is under. It is a lot of research is going on this topic. It will supersedes our human intelligence, and the people are very much afraid of this particular when the super intelligence will come and it will suppress our human brain. It may create some type of destructive activities. Another important part is analytical AI, functional AI, interactive AI, text AI, visual AI. This is depends on what type of utility we are going to get from the artificial intelligence. These things are very essential because when we are applying the AI to our civil projects, we must have certain knowledge about what is AI and how it is functioning. In analytical AI, we are going for the scanning of lot of data. That is your machine learning, deep learning require lot of scanning of lot of data. Then functional. The functional AI also similar to analytical AI, but the fact is that instead of only scanning, it will act. That is the functional AI. And what is interactive AI? It will take the feedback from the people. Any problem, you are unable to solve it, it will take the feedback and it will proceed ahead. That is called interactive AI. Text AI, speech recognitions, then conversion of speech to text. These are the example of text AI. And what is visual AI? Nowadays, a visual AI has taken a rapid improvement. Any type of analysis, region analysis, anything, from the picture, just sir told, from the picture we can recognize what are the defects and how to improve the particular situation that can be done through visual AI. So this operation of AI is done through a computer program, and this program are simplex, model based, goal based, utility based and learning based. Simplex means very simple, moving without caring for the past record. Model based requires some algorithm. Goal based, that means the end point, starting point, end point is known. How to proceed, that part is important, but without considering the path in which you are going to get. Utility based, instead of going from into a starting point to end point, a regular analysis is required and learning from the past experience. So these are all about your advantage, disadvantage you have already known. Now come to my topic. Why and how can we apply the water resource in the artificial intelligence in the water resource? So basically we can apply nowadays this machine learning and deep learning in the process of water resource. The machine learning is used for this predict water demand supply, quality learning from historical and real-time data. Similarly, for weather forecasting also, the machine learning is coming. In case of deep learning method, we can go for the more detailed analysis, leak analysis, pattern features in complex situation. We can go for the deep learning. So, what is the machine learning and what is deep learning and what is AI? Three different terms. AI is the main set. Subset of AI is your machine learning, and this deep learning is also a subset of machine learning. The bigger one is AI, then smaller one is your machine learning, and further smaller one is your deep learning. That means what? The machine learning we can go for very limited data. For this, we do not require any type of supercomputer or many high quality, high resolutions computer. But for deep learning, if you want to get more accurate result, then you have to go for the deep learning. For that, we can go for millions of data. For that, we require your CPU plus your graphics units also required for deep learning. So this is the very high resolution and high tedious tasks can be performed with the help of deep learning. So why you are using, what are the benefits in application of AI? The AI can give advantage for your what is engineering, just reliability is more, it is safe and secure, it can adopt sustainable and enable water management in a better way. So these are the reasons for which we are going for this AI applications in water resource. And what are the challenges ahead of us? As we know, the water resource system is a stochastic model. That means it is a prediction model. It is a probability. Rain will occur. If this much rain will occur, drought will occur. I don't know whether rain will come or not. It is only based on the prediction system. So that is the reasons why it is very limited things, limited data are available. Then the model are also very complex. And secondly, you have to go for legal aspects. These are the major challenges for application of AI in case of water resources. Now to apply this AI and artificial intelligence in the water resource, some skills are required, just like a Python, data analysis, visualization, Excel, SQL. These things are required. These are the computer programs are required. Some mathematical knowledge also required. This is man plus machines, calculus, linear algebra, probability. This knowledge is required. Then third one is one should understand the process. Unless a person able to understand the soft thing or software behind any issues, he cannot develop a model to solve in the AI model. So first of all, the understanding of the problem is required by the persons who is going to solve, who is going to apply the AI models for solving that issues. So these are the method we are using: machine learning, artificial, soft computing technique, genetic algorithm, particle swarm optimizations, cuckoo search, and many more. Lot of processes are available in the using MATLAB tool. So these are the applied in case of water resource. So these are the few example of very popularly applied problem to deal with the AI. Reservoirs operations. For that, your rainfall data pattern, water demand, reservoir operation, maximizing storage level, release time, these data are required. And the benefit is like this: water storage, release, flood control can be, or hydropower generation can be optimized. Second is water allocation optimizations. In this case, your water demand, availability, environment constraint to optimize the water. These data are required. That will promote equitable water distributions, user conflicts, water use efficiency. These are the benefits from that particular thing. Drought and forecasting, AI-based model, rainfall pattern, soil moisture level, climate data. These are the things essential for us. From that, we can able to predict the various things. Then integrated water resource management we have already discussed. This include weather forecasting, river flows, uses, and that is the benefit we are getting. Environmental impact assessment can be done also AI. Then real-time water monitoring and control with the help of the census data analysis. Also we can able to get the improvement to the water resource system. Then AI-based tool to helpful to the stakeholder also, to given data to the inside data, so that they can able to use the water resource in a very intelligent manner. Leak detection system also, and optimization irrigation system also. I have highlighted this particular thing because in the case study we will find how we have optimized an irrigation system with the help of this AI. For that reason, it is in the bold form. Apart from those uses, this also the AI can be used for hydrological forecasting and many formation of the decision policy making also. I can use these things for forecasting of dam inflow, machine learning used to decisions about the efficient water supply. These are the things which are required for the water resource applications. Now coming to very smart irrigations. The second application of AI is smart irrigations. So what is smart? Now the world is smart. So what is smart? Very specific, very measurable, attainable, realistic and timely. And what is the definition of irrigations? Irrigation is defined as continuous and reliable water supply to different crops in accordance with different needs. And when sufficient and timely water is not available to the crop fade away, resulting in lesser crop yield, and ultimately creating famines and disasters. So what is specific? At different time, at different needs, we should be in a position to supply water. Measurable, sufficient water should be available. Attainable, it should be reliable water source. Whenever we need water, we can be in a position to supply water. Realistic, attainable, available. Realistic is reliable and timely. So entire thing is present in the definition of irrigations. That means the smart irrigation is nothing a new one. We are just putting some value additions to the existing irrigation system. Then how? So before I go for smart irrigation, this is the common diagram for every civil engineering students. What is optimum water depth? How much water application is required by a plant? You can find this diagram in the SK Gork irrigation book. What is field capacity and permanent wilting point? Two different points you have to find out. What is field capacity? Can anybody BTech student can tell what is field capacity? The maximum water retaining capacity of the soil is field capacity. The maximum water we can apply to a soil. What is permanent wilting point? Beyond that, if we apply water, then the plant may survive, may not survive. So the first point is field capacity and point is wilting point. In between that, we are applying the water. So it is a common sense that people usually think if we put more water, the crops will grow. Not like that. So we have to go for optimal water depth. What is optimal water depth? The depth at which the production or yield is maximum is called optimum depth of water. And what is our major purpose of smart irrigations? We want to irrigate the field in such a way that the yield will be maximum. So now, what are the factors for which now smart irrigation is required? Initially, irrigation system is an old one, but now why we are talking about the smart irrigation system? There are few reasons for which the smart irrigation has taken its place. First one is weather variation, the climatic change. Second, the degradation in the soil quality. Third one is because this production has to be increased, and the prevention of the crop. These are the major few points for which we require the smart irrigation system. And how artificial intelligence is applicable or essential for smart irrigation system? Crop predictions, price forecast, intelligent spraying, predictive insights, agriculture robotics, crop and soil monitoring, and disease diagnosis. These are the certain fields for which we can apply the AI in your irrigation to make the irrigation smart irrigations. The first one is weather forecasting. Now the climate is changing everywhere, you will find. So this is also affecting our irrigation system or cultivation system. So based on this forecasting, we can go for the right time for harvesting, when to apply your seeds, sowing, harvesting, everything can be determined with the help of this system. Second, the price forecasting. If I give a earlier idea to the farmer when the cost of prices of the crop is going to hike, then definitely it will helpful the people to preserve the crops, and accordingly they can go for the markets where they will get maximum benefit. That financial benefit can be happened for the crops. Second one is health monitoring of the crops. Now the Plantix is a mobile app available in the market. It is a freely available software. From that, if you insert a photo of this particular plant in the mobile, in that particular app, it will give you so many informations. This is the deficiency of the soil, plant pest diseases, so many thing information we can get from this particular mobile app. This is available, developed by the German people, but now it is available in India also. It is a mobile app. So definitely this will help the people to get more information about the crop monitoring. Agriculture robotics. This concept is also working in India also. That is very useful. That is about performing so many complex tasks. Then intelligent spraying machines, when to apply the herbicides, when to apply the various chemicals to the field, and what quantity of chemical to be applied to the field and what time. These are things can be drawn with the help of this smart irrigation system. Next is disease diagnosis. This also, if we insert a picture of this particular plant, it can give the image. From the image, you can predict which part is affected with disease, which part is clear. That part can be done with the help of this AI system. And precision farming. That means when to apply, right time, right quantity, right place, and get to right product. That can be judged by this AI system. That is also one of the important application of the smart irrigation system. So basically, when we go for the smart irrigation system, there is two places where we can apply this. Basically, as I have told, the smart irrigation is to increase the performance of the existing system. There is nothing new. System is going on, we want to elevate the standard. For that reason, we are going for the smart irrigation system. So there are two different options is available for the smart irrigation. First one is the weather based or on-site soil moisture sensors. So we can depend on two things, whether we go for the weather based evaluations or whether we go for the on-site soil moisture measurement. That can be decided, that we can take a decisions based on the locations and the environmental conditions. First, let us go for the environmental condition. Evapotranspiration. What is evapotranspirations? Evaporation plus transpirations. Evaporation means losses from the water body and transpiration from the plant body. Altogether, it is called evapotranspirations, and we are applying the plants water to meet this evapotranspiration loss. To deal with this issue, the Food and Agriculture Organization has developed a software called CropWatt to decide how to and when to apply the water to the field. So this software is very much useful to develop an irrigation practice to increase the performance of the different farmers as per the soil conditions. The data available can be monthly, decade, daily way. If the data of a climate data is for a particular area is not available, that also can be available from the FAO. And it is graphical presentation is very useful for us to determine the water to be applied. Basically, it has 8 modules, 5 input module and 3 output module. Climate, here I can go for the maximum temperature, minimum temperature, wind velocity, so many input climatic data is required. Rain data, from that the amount of rainfall and the amount of effective rainfall, means rainfall minus losses, which will come into use. That part we can determine. Types of crops, the field capacity, wilting point, root depth, that part of data you have to provide. Then soil, then cropping pattern, that is tells about the intensity of the irrigations, what type of crop we can cultivate, and what area we can go for cultivations. That can be these 5 input data you have to provide in that particular crop wide. Then the output will be crop water requirements. This crop water requirements will tell you how much water to be applied in the field. Schedules, when to apply the water, and schemes, the method of application of water. So if we apply these 5 input, climate data, rainfall data, crop data, soil data, and cropping pattern, then we'll get the output CWR, schedules, and schemes. These are based on weather. So the weather data I can get from historical or from direct field measurement, and from the signal based control system, meteorological data. This data can be obtained. NIC also can provide this data. The second method is soil sensor for the smart irrigations. In that point, we have to find out how to measure the soil moistures. Basing on that, a sensor is used, and that the student is available. He will show you a model how this smart irrigation is used to control to know about the water content of that particular soil. So basically, there is two types of sensors are available. One is suspended cycle irrigation system and water on demand irrigation system. What is suspended cycle irrigation system? That means the start time and duration time is fixed, time bound. If it is found that the soil is sufficient moisture is available, it will not repeat the system. So based on the timer system, this first one provide you the water. Second is on-demand irrigation system. That means you have to provide a range, the wilting point to field capacity. Once it will reach to that amount, then automatically it will cut off the supply of water. These are the two methods are used in the smart control irrigation system. And these are the there is how can you measure the moisture? I have taken this from this particular paper I have mentioned below. The microcontroller, soil sensor, servo motor, temperature sensor. These are the some layout of the your microcontroller system arrangement through which we can able to know the moisture content. The soil sensor, I think we will going to show soil sensor. Yeah. So in that particular soil, when the soil is very dry, in that case, what? The resistance is very high, so current is less. When the water will flow, ultimately what will happen? The resistance will be low and current will flow. So at what level this supply of water can be cut off? That is the basic principle of this soil sensor process. Similarly, the temperature sensor, this is also available. Suppose we set for a particular field, we require 40 degrees centigrade temperature. That means in that case, the operation of pump also depends on how the temperature is increasing or decreasing. That can be also applicable with the help of the sensors, but it is small scale. Then servometer principle is also applied. What is servometer principle? Just like your filling of bottles. In a particular angle, the liquid is coming up. In the industries, the bottle is there, they are filling it. Like that, when we are applying the irrigation system, at what directions, at what angle we can spray the water, that is can be determined with the help of the servometer and rotating platform. And these are the working principles we have already discussed. Now coming to next one. This is the figure you have seen in the SK Gaur book again. It is a common paper thing telling all about your distribution system, the main river, branch, canal, distributary and field channel. So why I am showing this figure? Because the moisture can only controlling the moisture at the field level is not sufficient. We need to control the supply of water at the field also. So these are the system. Irrigation system is what? Artificial supply of water. So it can be happened. It can be achieved with the help of this number of canal system. So this flow, depending on the type of flows in the canal, how much water is flowing in the canal, we can go for the planning of the crops. So these are the two very recent instrument is available in our university also. VSSUT Bulla also it is available. We have done a lot of project on this acoustic Doppler one, another is macro LED. So what is this one? You just see the screen is there. Here you will find three different, one transmitter and two receiver. The middle one is transmitter and other two is receiver. So what will happen? Suppose if I put this instrument in the water, it will send some signals and the signal will intersect with the sediment particle. Whenever the water is flowing, the sediments are also flowing. When the signal sent by this transmitter will collide with that particular sediment particle, it will return back. So depend on the what signal, at what signal we are sending the at what frequency we are sending the signal and what frequency after reflecting from the sediment particle it is returning back to receivers, we can able to measure the flow. This is the views of the ADV flow trackers. Similarly, for better, this is 2D, this 3D. In both X and Y and Z direction also we can able to measure this velocity, and from this we also can find out various turbulence property, many properties of the flow can be determined. These tools are very useful methods to determine the flow quantity in a field. So once we know the field quantity, how much water is flowing, how much water is available to us, we can go for the crop planning. And this is my case study. These are the Hirakud canal system. And out of this, I have chosen, today I am going to present the Parmanpur distributed system, how we have applied this AI technique for better irrigation projects. This is the crop plot, as I have told. We have taken the entire maximum, minimum temperature, humidity, wind, sun, all the 5 input model data from 2008 to 2023. We have entered in this particular month wise. Then ultimately, this is the output model in the red color. So last one is your evapotranspirations. So as per this figure, this is all about your Sambalpur stations. Just see. From that, what I found, I plotted this whatever. This is the last column. You just see that one is plotted here. And what I found, the evapotranspiration is of Sambalpur station is found to be 4.43 millimeter per day. And this variation as different seasons is only because of this climate conditions. And finally, this is recorded in the terms of decay. April 2-3 means 20 days. April 20 to 20 days. Then May 1 to 3, 30 days, 10 days interval. June 30 days and July is 10 days. So I have taken the example of plagram to show how I can find out the water requirement for this particular crop. So this is an example. So what I found, the total period for cultivation for this particular crop is 90 days, and this is look like this. From that, this is my evapotranspirations, what I got, millimeter per day, then decade multiplied by 10, then I got this one, then effective rainfall I got, the total evaporation required, evapotranspiration required, ETO required, minus effective rainfall will provide to the irrigation requirement. So in this way, what I found, it is maximum 54.6 in case of May. Why it is highest? Because definitely during the May, the humidity is very less, temperature is very high. If you go to July, you will find 0 requirement. So altogether, what I found, my evapotranspiration is total requirement is 451.6. Out of that, this amount of water required for this particular crop. Out of that, I am getting 167.9 from the rain. So rest to the rest amount to 84.4 that I will require from the irrigation system. This is April 2, May 3, and then June 3 and July 1. So from that figure, what you will find, you just see the maximum in case of this May month is highest. So this is the highest. 72. Out of this, the gap is your effective rainfall, blue is your irrigation requirement. Green indicates total ETO requirement. Blue represents, the gap represents effective rainfall. The blue represents the how much water is we can apply to the field to fulfill our demand. This is the one method I can find out the weather base to know the water requirements. Then to suggest a cropping pattern, we have derived some optimal pattern. Total benefit is equal to net, what is the objective function optimizations to maximize the benefit of the farmer. So total cost minus cost of fertilizers, cost of seeds, cost of labor, cost of water. I put all the expenditure in one side and benefit in the one side. P, that is the my yield, rate per quintal, this is quintal per area my yield. P stand for price, basic price. A stand for area. Similarly, if I go to fertilizer cost, seed cost, here also I have given the cost of particular fertilizers, that is I can apply for kg per hectare, kg, and what is the cost. In that way, I found the data for each and every crop that I am going to cultivate in that particular catchment area. And every optimization techniques, every optimization problem has certain constant. One is water availability. As I have told, we have applied the ADB flow trackers and micro ADB to determine the discharge. So whatever water requirement by my plants, crops, the cropping pattern should not exceed my total water available in the field. And what is the total water available in the field? It is theoretically different, but actually we have measured with the help of this ADB and flow tracker ADB. Then The whatever land we are going to cultivate should be less than available land available. Third is crop constant, because we cannot suggest any cropping pattern to the farmers by force. They have certain own requirements, just like you maximum people here adopting rice crops, and this is the rice bowl of the Odisha state. So you cannot implement any type of compulsorily, you cannot compel the people to go for this type of cultivations. So depending on their options as well as the views of the agriculture extension officers, we have given different percentage to the crops, and they have made permutation and combination so that the benefit will be maximized. Then there should not be any negative constant. So basing on this optimization model, what we did, we applied different type of optimization techniques. The first one is Kuko search algorithm. The Kuko everybody knows is a very beautiful bird and very nicely singing capacity. But how these optimizations, as I have told, the AI model can be developed from the knowledge of any plants and animals and the human being. Natural process we can develop AI models. So what is the utility of this one? This bird is very selfish. See normally what is always during the breeding period, she always moves here and there to find out a suitable nest where the host bird, means other bird, is going to let her eggs. So what will happen? This bird will put her egg in that particular nest of the host bird. Suppose that white one is the egg of this particular cuckoo search bird. Then it has the power, just like your artificial intelligence computer can mimic the human brain. They can knuckle. Mimic means they can knuckle, in Hindi word is knuckle. So they can change the color of that particular bird. So here also this cuckoo search bird will take the color of that particular host bird, and she will put her egg in that particular nest. Now the job of the host bird will come. Suppose the host bird able to recognize this egg is not mine, it is the egg of the cuckoo bird. Then what will happen? The host bird will throw the egg. That means the solution of the cuckoo is not feasible, is not fit. So if the host bird unable to recognize this egg is of not mine, if she recognize this egg belongs to me, not for cuckoo, that means what will happen? This egg will survive and will go to next generations. So like that, this is the process by whichever is feasible solutions in a particular problem, we define the problem, we prepare the algorithm, and we can move. This process, anywhere the fitness is not applicable, we are unable to get the required type of fitness, in that case we go for if the fitness is okay, we can go to next step, we get the better solutions, otherwise we have to go back. Similarly, the particle swarm optimization algorithm. Particle means bird, swarm means combination of bird. So what is their basic purpose? They always in search of food. They are moving here and there in search of food. When they are moving, they are optimizing their positions. Two things. One is local based and global based. I can explain this in a better way. Suppose a student appear in examination in the first terminal 40%, second 90%, third 80%. So the highest percentage is personal based, P based. But in the class, suppose a person is getting 99%, then that is the global based. So P based and G based, two things are very important. Why important? Because when the bird is moving in search of the food, the bird is changing its own positions as well as is changing her position with respect to other birds also. They will move ahead in search of the food, and once they will reach to the food, their search is over. If they are unable to reach, to diagnose, to find out the exact position of the food, they have to go for they have to move to another direction. Like that, here also the velocity and the position both are changing. This process we can apply to develop our cropping pattern. And very famous one, genetic algorithm, this based on Darwin theory, the fittest will survive. So we have to find out the solution which are very much fit means very close to our output. Then the process of crossing over, mutations just like human beings. You have to proceed, and if the output is as per our requirement, then we will proceed. Otherwise, you have to go for the second process. I have shown three techniques: search, PSO, and GA. But other techniques also available. There is human-based, human-inspired, plant, animals inspired, and calendar organism, PLBO, teaching learning based optimization. So many methods are also available that can be applied for this purpose. And these are the outcome what I got. This is the from the GA. I got 229.7 million rupees from this by adopting the cropping pattern suggested by my model, which is 97.5 lakhs more as compared to the present cropping pattern. And how much area to be cultivated, what are the crops can be grown, I've given, and what is the percentage of area to be allotted, it is suggested by the model. Similarly, I applied the same thing, same data to my search algorithm. Here same, this 45 nest I have selected and I have given 2000 iterations, and finally what I got the result is 229.895 million rupees of benefits, which is more than 97.67 million rupees to the present cropping practice. And these are the area suggested by my model where what type of area I should go for cultivation of different type of crops. Then I applied the particle plant optimization technique to same problem, and I got the net benefit of 230.12 millions by adopting this cropping pattern. So this is the suggestion, the screenshot of the output that I got from my computers, from my programming, and this is the cropping pattern suggested by the PSU. So finally, this is the present practice. This is the very common Lindo practice optimization model. Then genetic algorithm, search, and PSO. From I compare the benefit, you just see the slight variation in the three methods that I obtained by application of the artificial intelligence, almost very negligible difference. And as compared to present practice, that 132.2 and the highest one is 230. You can find a huge difference in the benefit of the people if I adopt the predict and adopt the model suggested by the model of artificial intelligence. And these are some of my conclusions, very shortest conclusions I have got. Now for the future of water resource, it is very essential for us to the application of artificial intelligence, and in the field of hydrology and water resource, the very complex system. It is a stochastic system. So you have to apply these AI techniques for better result. And the smart irrigation is also a promising system of irrigations, which is highly required for better improvement of the irrigations. Then smart irrigation will not only save our time, but it will guide us how to provide right amount of water in right time, so that the waste of the people will be decreased, and definitely will get a better output from the every drop of water, because water is a major scarcity, major challenges ahead of us. This is all about my presentation. I have taken some of the reference book like this. Thank you.
You have seen what is the concept behind this smart irrigation. Now we are inviting one small kid on this ground, smart irrigation ground. Is none other than Siddharth Jain, and he is with his teachers of Indian Public School of Sambalpur. So Siddharth Jain, you are requested to tell something about your project, then we shall be starting that. Okay, Siddharth, please. You are on live streaming. Can speak in Hindi.
Good afternoon, sir. Myself Siddharth Jain from class 9. Today I am standing here to show my project, that is smart irrigation system. First of all, I would like to say thank you to sir for inviting me to demonstrate my project. Now I will say about the project I have made. The main parts I have used is Node MCU that is used for remote monitoring and data platforming. Second one is soil moisture sensor that is used to sense the soil moisture And third one is relay module to switch on and off the circuit board. Fourth one is DC pump for water source, and fifth is 9-volt battery to give power supply to water pump. I have used also power bank to give supply to node MCO. The main feature of this project is the people who cannot give water to the plant, they can stay anywhere throughout the world. From internet, they can give water through internet. The main advantages of this project is you can stay any place throughout the world and give water to the plant and check the soil moisture sensor. You can control it through mobile from a single click and check the soil moisture sensor. Thank you.
Now the demonstration of the project will be there, and you people, you can also check the validity, and I shall be requesting Asutosh, please check the validity of the project, because you belongs to this field. We are not understanding much on this. And anybody from the participants also, you can check the validity, because I have also seen him working in the science exhibition. I have also checked the validity. So you are also requested to check, because it is a very normal problem when we are going out from our house and we are thinking about our plants, what to happen to our plants. And this model will be very useful for irrigating our plants. Now it is very good, very good, very good. So live model. Yes, you can.
मैंने इस सर्किट को पावर बैंक से सप्लाई दिया है और ये वाटर पंप को बैटरी से सप्लाई दिया है ताकि ये मोबाइल से कंट्रोल हो सके। फिर मैंने वाटर पंप को पानी में डुबा रखा है ताकि वो मैंने इंटरनेट से हॉटस्पॉट के थ्रू कनेक्ट कर दिया इस सर्किट को। अभी मैं इसको मोबाइल से सिंगल क्लिक में चालू कर सकता हूँ, पानी दे सकता हूँ। पानी जा रहा है इसमें सॉइल। हाँ 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 नहीं मैंने ये सॉइल मॉइस्चर सेंसर को सॉइल में लगा रखा है और इसको सर्किट से पावर सप्लाई देंगे। अभी ये सॉइल मॉइस्चर भी दिखाएगा, पानी कितना सॉइल मॉइस्चर, इसमें सॉइल मॉइस्चर दिखा रहा है 2 है। सिंगल क्लिक से ये पानी दे सकता है और सॉइल मॉइस्चर सेंसर दिखा सकता है। आपको जितना पानी का रिक्वायरमेंट है आप उतना दे सकते हैं। गुड मॉर्निंग सर। गुड मॉर्निंग सर। सर सर सिंगल क्लिक से चालू हो गया ना सर पानी।
You can go to a distant place and check out.
सर सॉइल मॉइस्चर सेंसर से मॉइस्चर पता चल रहा है इसमें। हाँ।
That means the moment he is
Papa,
operating his
पानी।
mobile, you are getting irrigation.
हाँ।
The plant is getting irrigated. That is the main thing. Then
हाँ। हाँ।
you go to some other place.
Yes,
Go to
sir.
some other place. That means here left is up.
सर चालू कर दिया। मॉइस्चर दिखा दो। वहाँ पर चालू हो रहा है। मॉइस्चर दिखा रहे हैं उसमें कितना क्वांटिटी पानी प्रेजेंट है। 25। हाँ। भैया ऐसे चल रहा है। हाँ पानी दे सकते हैं, मॉइस्चर पता चल रहा है। मॉइस्चर 22% है। हाँ 24।
ज्यादा मॉइस्चर हो जाए तो अपने आप बंद हो सकते हैं।
वो आप मन कर सकते हो, आप देख के मन कर सकते हो। हाँ।
कंटेंट रहना चाहिए।
आप जितना दे सकते हो। हाँ आपको हाँ ब्लिंक ऐप है, एक एप्लीकेशन है ब्लिंक, उसे हाँ आप अपडेट कर सकते हो। हाँ वो पानी वहां दे देगा। हाँ मॉइस्चर बढ़ते जा रहा है। इसमें और भी फीचर्स ऐड कर सकते हैं, टेम्परेचर, ह्यूमिडिटी, ये सब के लिए। वो सॉइल मॉइस्चर सेंसर यूज किया जिससे वो सॉइल का फर्टिलिटी और मॉइस्चर दिखाएगा कितना वाटर प्रेजेंट है उसमें। वो एडवांस फीचर्स ऐड करने से हो जाएगा। अभी नॉर्मल फीचर्स ऐड किया हूँ मैं उसमें। हाँ ऑर्डिनो। थैंक यू।
anybody
You-
can go
you
to
can app-
any other place. Go to any other place, check the soil moisture, and then check whether the irrigation is being done.
ऑफ है। पानी जा रहा है। हाँ ऐप चाहिए ब्लिंक। इसमें सॉइल मॉइस्चर दे सकते हैं कितना वाटर प्रेजेंट है।
That means we can control through permanent wilting
30%.
point. Permanent wilting point, field capacity, these things we can add on here so that whatever our friend Asutosh has told,
इसमें और भी
that you
फीचर्स ऐड
can,
कर सकते हैं.
relocate all this
ये भी
here.
सिंपल बनाया हूँ.
Because as per his knowledge, he has developed. As per your knowledge, you have to modify it. So that the canal system can be possibly, you can check comment କରିବା କଥା ଏକୁ ଡେଭଲପ କରିବା କଥା ଏକୁ
You can use.
modify କରିବା କଥା ସେ ପିଲାଟା ତା ବୁଦ୍ଧିରେ କଲା ସେ ଫିଲ୍ଡ କାପାସିଟି କଣ ବୁଝିଛି ସଏଲ ମଶ୍ଚର ବୁଝିଛି ସଏଲ ମଶ୍ଚରର ସେ ଇଏ ଲଗେଇଦେଲା ସେ ଜାଣିନି କୋଉଠି ସେ ଯୋଉ ଅପଟିମେଟ ହବ still he has not understood duties and time. You have understood. So modify it. Develop.
हाँ?
कोई मेजर क्वेश्चन
हाँ, वर्ल्ड में कहीं भी. हाँ, इंटरनेट चाहिए. हाँ. वो प्रोग्रामिंग करते समय वो यूज करते हैं मोबाइल का वाईफाई पासवर्ड वो सब. हाँ. हाँ. कोर्स जीपीटी कुछ वेबसाइट था उसमें से. हाँ, चैट जीपीटी उसमें से कोड को बिल्ड किया. सर वर्ल्ड में कहीं भी. यस सर होगा. हाँ, बस इंटरनेट होना चाहिए.
प्रोग्रामिंग करो. हाँ.
जितना ज्यादा प्लांट होगा उतना उसी के ऊपर डिपेंड करते कितना बोर्ड लगेगा.
वैसे बना सकते हैं जिससे कनेक्शन
हाँ.
सॉइल मॉइस्चर वो सब में
नहीं ऐसा जरूरी नहीं है. जितना बड़ा प्लांट होगा उसके लिए उसके ऊपर डिपेंड करता है. ये अभी छोटा प्लांट है तो इसमें 2-3 और ऐड कर सकते हैं हम. तो बड़ा फार्म के लिए हमको 2-3 चाहिए होगा. हाँ, मैं ऐप डिजाइन नहीं किया हूँ. ऐप पहले से प्ले स्टोर में अवेलेबल है उसमें यूज किया. नहीं वो प्रोग्रामिंग में सेट करना पड़ता है तो वो उसको सेट करके वो दिखाएगा फिर.
इसलिए एक्चुअली एआई में कोड लिखा हुआ है डेवलप किया कोड डेटा नहीं सेंसर्स को डेटा भेजने कोड प्रोसेस कर.
हाँ. हाँ वो एक्स्ट्रा वर्क करता है वर्ल्ड में कहीं भी. हाँ. आएगा. अभी फीचर ऐड नहीं किया. फीचर ऐड कर सकते हैं. मैंने ऐड नहीं किया उसमें भी दिखा देगा कितना.
कैन कीप रिकॉर्ड्स.
हाँ रिकॉर्ड रख सकते हैं. अच्छा थैंक यू. कोई यूज करना नहीं कितना भी वाटर ले सकते हो आप. मोबाइल में जितना जितना परसेंट आपको वाटर चाहिए वो दिखाएगा. हाँ
पानी जैसे.
हाँ.
जैसे कि डिफरेंट प्लांट्स में डिफरेंट पानी का क्वांटिटी रहता
हाँ.
है तो उस हिसाब से
हाँ उतना दे सकते चेंज कर सकते. थैंक यू. थैंक यू. हाँ. थैंक यू. थैंक यू.
सर 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 पिक्चर वन फोटो सर. एक्सीलेंट.
थैंक यू सर.
Very good.
Yes, sir.
The kind of
Yes, sir.
yeah,
Thank you.
they're also in the same kind of thing, but we are not.
Thank you, sir.
Yes.
Small area.
So think of joining number of
Yes.
so these may not have similar type of crop. We are not European country. In our crop still there are two or
So first I have decided to add more features, sir. Much time is not there, sir. Thank you, sir. Yeah.
Huh. You can. You can. Abu. सिद्धार्थ जैन एंड टीचर अंसार खान साहब पेरेंट भी उनके हैं, उनके भी धन्यवाद हम करते हैं और वी आर इन द लास्ट पार्ट ऑफ टुडे एंड नाउ द फेलिसिटेशन विल so the two resource persons we are having with us, Dr. Pradeep Mishra Shah and Dr. Asutosh Ratha, and the lectures were excellent and that taught our participants, those who are working in the field of irrigation, remote sensing, GIS, and we are now understood that how useful all these things. And lastly, Siddharth, the way he has shown, and definitely I am particularly more motivated that the things should be going in the smart way practically. Practically, the things should be going on in that way so that the irrigation system can be developed. And as Asutosh has developed so many things and the critical equations and the technologies. So if these two will be amalgamated, then the things could be somewhat changed for our state. So SAR has given a very good impetus on the remote sensing GIS applications. And those students, those who are working in the field, the research scholars, those who are working in the field, for them it is a nice lecture, and techniques also, whatever the techniques Sir has told, that taught everyone. So thank you, both research person, Siddharth, and his parent and research. So now we shall be coming to the felicitation. So please go ahead.
Thank you, sir. Now I would like to call our two dignitaries on the stage because we are going to give the token of thanks from V. Surendra Sahib University of Technology. So I request both the dignitaries please come to the dais. And I request our coordinator, Professor Anil Kumar Kara sir, please felicitate the dignitaries. Give a huge round of applause for them. Thank you, sir. Thank you for coming and give your valuable time to us. I would like to call the junior, the Siddharth Jain, please comes to the dais with his teacher, Ansar Khan. Please, sir, come to the dais. Give a huge round of applause for them. We are also going to fellowship the teacher. Thank you everyone. Thank you for your unflinching attention and patience hearing. Now we will take a group photo. After that, please join us in the lunch. Today's session is over. We will meet tomorrow. Thank you. Please everyone join for a group photo.